So today we're going to speak about how to leverage GraphQL to efficiently query Salesforce relationship data. So before starting, quick show up of hands. Who knows about GraphQL? A little? OK. So basically, GraphQL is a project that has been released a year ago by Facebook. And during this year, the project has made a lot of progress and finally reached the last month the stable version. And there is more and more traction around that. GitHub released their first public API based on GraphQL. And that's why I'm really pleased to be here today to speak about how you can leverage GraphQL on Salesforce. So first, what's GraphQL? How to build your GraphQL server and leverage it. And finally, what are the advantages, but also the drawbacks of using GraphQL compared to the other available solutions. So, as usual, before starting, the forward-looking statement. But first, let me introduce myself. My name is Pierre. I'm working at Salesforce as a performance engineer, and I'm based in Paris.
Hi, everyone. I'm Robin. I'm a full-stack engineer working every day with GraphQL in a small French startup named Desktop. And I'm glad to be presenting it to you here, this technology that I really, really love. So first, a little bit of context about GraphQL. GraphQL has been created in Facebook and is in production in Facebook since 2012. It has been created to migrate from their old HTML5-based application that was kind of slow and had a kind of bad UX because of performance issues, and they wanted to transition that to a native application. However, the problem is native development is completely different than actually web development. Some of you may know that. And for example, fetching data in a native application is quite difficult. And for Facebook, they had to create something new to tackle this problem. So, many companies, since the open sourcing of GraphQL started using it, obviously Facebook is the biggest GraphQL consumer, but you can see recently GitHub that released their public API, and you can see, for example, Pinterest, Shopify, or even Meteor that is migrating its technology stack to GraphQL with something called Apollo. We're going to talk about that a bit later. So, in order to demonstrate to you the key features of GraphQL, we created a small application that is actually listing movies, actors, and seeing the relationship between those movies and those actors. So all of the actors in the movies are stored in Salesforce, on the Salesforce platform in custom objects in this demo, and we are getting some complementary metadata from the MovieDB, which is a third-party API. This application is made with React Native, and it took us only 2 days to develop, and we were just 2. So I'm going to show you that right now. So here's my iPhone. Yeah. OK, so here I'm listing the different movies. You can see that actually I'm already seeing the actors. So I can just go inside the application and kind of see the relationships between the movies, the actors, and everything. So for example, let's take Samuel L. Jackson. And you see that he played in Django Unchained as well. So the application basically is able to go through your different Salesforce relationships. So
basically, like, before going further, GraphQL is a way for us to communicate between the server and the clients. But as you maybe know, there are plenty of ways to do that already on the platform. So why not using REST? So if we want to build this page, so the movie list, we're going to first fetch the movie on the server. So the movie is represented as a resource. But if we are using a default REST API, basically, we're going to receive also the ID of the actors playing into this movie. So we need, after that, to send requests or a batch request to fetch the according actors. So there are many issues with this kind of architecture. First of all, you need several round trips to fetch your data. But also, you need to coordinate all those round trips because you can't send them before having the parent resource. And finally, something which is hard with REST is that you can't require and request a specific shape for our data. So in the case of this page, the actor listing, we only need the name of the actor, his picture, and the character that he played into the movie. And if you are using REST, you're going to receive the entire blob of data. So this leads to overfetching, which is bad for a mobile application. So why not using SOQL or SQL-like approach for building those kind of application? The thing is that, as you can see, here is a small example of what's the data shape that we have for building the movie QL application. We have an actor and a movie table, and there is a many-to-many relationship between them, and we are using the junction table role for linking those. But as your application grows, basically, you're going to create more and more complex queries. And this is hard to maintain if you are exposing those APIs to the clients. But also, as you've seen before, we don't store all our data on Salesforce. So if we are using a SOQL-like approach, how can we fetch data outside Salesforce? So basically, if both of those approaches is not really what we want, most of the time developers go to an hybrid approach with this by building custom endpoints, mixing both the standard REST API and the SOQL API as well. But the thing is that this has a huge maintenance cost. So, for instance, if your product manager is coming to you one day and say, "Oh, I don't like the way the movie is shown in the list. I don't like, displaying the year. I would like rather to display a tagline of it." So what do? You go to your backend engineer and say, "Oh, can you change this field by the other one?" And after that, you have to update the code on the front end as well. So that requires a lot of cycle only for changing a field. But also, this leads to some issues with versioning. If you have in the wild, basically, several versions of your application, and some of your application is in the previous version of the API, and the new version is, the other application is consuming a new version of the API, you have to maintain both of them at the same time. And that's an issue as well. So coming back to the high maintenance costs.
So we are going to introduce GraphQL to see if that can solve some of those issues we just see, and why not get something more out of GraphQL. So GraphQL is based on those, for me, 4 principles that are really important. And first of all, GraphQL is going to be declarative. So you're going to ask only what you need and what you want, and nothing else, nothing more. It's going to be strongly typed. So basically, GraphQL will be constraining you in some ways. So you won't be able to do anything with it. And that's actually great when you're a client application. You don't want to give too much rights to this client application. GraphQL is also composable. That means you can create pretty complex queries more easily by reusing parts of the queries. And finally, and that's really an important point, especially in our case, GraphQL will just be an execution engine. It doesn't need any kind of database behind it. You are going to define to GraphQL what you needed to resolve. So, first of all, this is a GraphQL snippet. If you know a bit of JSON, it looks like some JSON, and that's actually the goal. So you are requesting in this movie some ID, title, year, and then you are going to go through some relationships, characters, gets the role name, and then the actor. So we're going to use GraphQL, which is a small IDE by Facebook that is made to help you create GraphQL queries and execute them and directly see the results. So here you have some JSON. So you see the shape is exactly what you wanted to have. You see it's completely corresponding from both sides. And in the example here, if my product manager comes to me and wants me to change the year, I just have to do that and re-execute the query. And then I have my change in the query, my data requirement just change. So secondly, GraphQL is strongly typed. It won't let you do things that are impossible, that are not defined by the system. So here, the strongly typing tells me, okay, I don't have any average vote field on my query. That I can't do that. However, graphical, since it already knows the type system, it can actually introspect the type system and get me the suggestion for me and correct my query and make it run. And since everything's typed, documentation is auto-generated from that. So I can see exactly what a movie can be and what it actually represents and which relationships it has with, for example, characters and so on. So you will be defining this schema as a developer. That's really important, again, and we'll get to that later. You can create really complex queries with GraphQL, and in order to help you build those queries more easily, you can reuse what we call fragments. Fragments are like small bits of queries that you can reuse at multiple parts. So here, for example, my fragment is appearing here, and as well as at every iteration of my list. But from that, I can just change my fragment, and I'm going to get the same results everywhere. So here, I'm listing the movies in which each actor is playing, and if I do that change in the fragment, it's going to be changed everywhere the fragment is used. So from that, we get to the final point, and one of the most important. It's just an execution engine. So on a single GraphQL endpoint, you will be able to query both, for example, our Salesforce platform, as well as getting some complementary metadata from the MovieDB. For example, in MovieQL, we're getting the picture and the average score from MovieDB. And since you have this unique endpoint, you're going to be able to query it with any HTTP client available. So I can use curl for my command line, but I can as well use my native client, native application client, or an XHR if I'm working in the browser. So this application has been created with the following tech. So here's the tech stack we used. We are running the server, the GraphQL server on Heroku. It's running on Node.js and using the Apollo server tools made by Meteor and the reference Facebook GraphQL implementation. On the client side, we are using the Apollo client that will help us with things like caching. We're going to get to that later. And React Native to show you the UI. And we access the backend using just Node APIs, so JSForce in this case, and just an HTTP request to get to the MovieDB.
So, thanks, Robin. The thing is that now that we've seen how the stack works, let's see how you can leverage GraphQL and build your own schema for your application. So first, before starting, if you want to build your GraphQL server, you have to define the schema. So in order to do that, everything is GraphQL is represented by a graph, basically. And everything is strongly typed. So in order to define the nodes in your graph, you need to define the types. So in our case, movie, role, and actor. And each of the fields of those types are also strongly typed. The exclamation point at the end of the fields are saying that, for instance, the ID is a non-nullable type, for instance. Well, the thing is that now that we have our nodes living in our graph, we have to connect them and create a relationship. And this is done as well via the type system. So a movie is linked to a character list via the movie is linked to the role via a character list, and also the role is connecting to both the movie and the actor as well. And now that we have our graph, we need to provide access point to the developers to go through this graph and navigate it. So we are doing that via the route query. So the route query is exposing two types of entry points. A listing entry point, which is movie and actors, that retrieve all the actors and the movies present in our graph. And also the parameterized queries for movie and actor that allow us to fetch a single one of those. And this root queries is used into the schema that we expose. So now that we have our time system in place, how can we fetch data from the different sources and aggregate those to create the response? And this is done via resolvers. So before going further, that's really important to understand how the resolver works. A resolver is a function that returns a promise and takes 3 different arguments. The first one is the base object. That's the object that we are currently resolving. The second one is the argument that is passed via the parameterized query. And the third one is the context, which is an object globally available in the resolution of the query. So let's see how it works. So for instance, here is the resolver for the movie. So I want to fetch a single movie, and this is on Salesforce. So I'm gonna issue a SOQL query on Salesforce and get from the argument passed in the parameterized query the ID of the movie that I want to retrieve. And then I take only the first result of the SOQL query. Now, if I want to fetch the average votes, this data is living outside Salesforce. This is living in MovieDB. So what we are doing is that we are using the object that we are currently resolving. So the movie record that has been fetched on Salesforce gets the MovieDB ID associated to it, issue a request on the MovieDB API, and fetch the field that we want. And finally, for illustrating the context, if we want to make authenticated queries on Salesforce, how does it work? So basically, you're interacting with your GraphQL server using standard HTTP requests. So when our node server is receiving the incoming request, the request will first go through the authentication middleware. In this middleware, we're going to create a living connection with Salesforce and make sure that the user has the right to query the instance. And now that we have the connection with Salesforce, we inject it into the context. This will be available in all our resolvers. So if we want to do it, we can use the third parameter of the resolvers.
So now we have a server that we just created. Yes, we can consume that and issue queries using GraphQL, but the main point of GraphQL is to be used on clients. So you want to develop an app using GraphQL, and we'll just see how that works. So let's take, for instance, this component, which is just a view listing movies. This component, its only role is to list the movies and just delegate the rendering of each row to another component. So basically, the query associated to this view is going to be just a query asking for listing the movies. And that's exactly what this query is doing here. But after that, we are going to use a fragment to delegate that to the next component. So the next component is the row. The row has its own data requirement, which is the movie row fragment, and it's just describing what we need to show it. So for example, here we have the title, the poster URL to get the small image, and the year, and then we are going to again delegate this concern to another fragment afterwards. This fragment will be the movie row character, and it's just defining what we need to show those small actor faces with their name. So let's wrap it up on the other side. So we are just taking the movie row character in the movie row, so we can use that to render the movie row correctly. And then we are going to just take the movie row fragment to show in our list every stage of the list. So that's basically what we call colocation. And colocation is the only thing you are going to code in your application. You are going to code components that will take from one side the data requirements and then just a rendering method. So let's take, for example, all of our system. The movie list is the first component that will just use the second component, which is the movie row, and then the movie row is going itself use another component. And that's all you need to code. Then the client is going to take up from there and handle all the hard stuff. So here, the data request is coming out from your fragment or your query, and is going to be asked to the client. The client is going to check with the cache, its internal cache, to see if there is not already the data. If it's not there, it's going to do a round trip with the server, only asking what you need. And then it's going to cache that, and obviously just pass it to your rendering function. So you have finally your data integrated into your rendering. So in order to show that, I'm going to just demo to you how that works, the caching. So here we have our Heroku logs to see exactly when a query is going to be issued on the server. And we have here the application. So the first time the application is going to boot, and it's going to make a call. So here we see that the query just went and got results. Then, yeah, let's try this one. Again, we're querying again because we don't know still, our client doesn't have the data yet. If I just come back, I'm not reissuing anything, and if I come back here, again, that's cached, and I don't have to do anything to manage this cache. The client's doing that for me. So getting back here, one of the main questions you may ask yourself is, okay, I have this client, but how do I manage the cache? I mean, do I do invalidation, stuff like this? And that's not something we're going to cover today. There are many resources that we will link to you later. But the first resources to do cache invalidation is mutations. Mutations are like queries. Instead of queries, however, they are going to change your data on your backend services and return meaningful results to help your internal cache to update itself and get the latest and greatest data. So mutations are really important in GraphQL, and if you do a big application, a bigger application than the one we did, you are going to need them. A point that we didn't talk about now, but that is really important about GraphQL, is that GraphQL is defined by a specification. And this RFC specification that has been published by Facebook is describing in every way what GraphQL is, what it can do, how the syntax is working, and how the execution engine is working. And that enabled many people in the community to create implementations in other language than just JavaScript. Here we just show you how to do that with JavaScript, but you don't have to use JavaScript to do some GraphQL. If you are using Python, Java, anything, basically there's really good implementations made by the community. For example, GitHub is using Ruby implementation that is actually really good, and they plug that into their Redis application. And there are also other clients. We just showed you how Apollo works, but for example, Facebook has its own client, which is called Relay, and that just is pluggable into React. There are some differences between those clients, but every client you will choose will have some advantages over the other. Depending on what you want to do, there's many different possibilities. And the community is always active. It's always researching some new ways to do things with GraphQL, and we're coming up with pretty good ideas lately. The problem is GraphQL is not made for everything. You have to be careful. It's not a silver bullet. You're not going to use that to do RPC calls, for example. You are not, for example, going to use GraphQL to do complex SQL-like queries. like having like queries or comparison queries, you're not going to go freeform in your querying engine. That's actually wanted by the type system. You don't want to expose to your client freeform possibilities, because either that will end up with a possibility of injection, and this enforces a kind of security in GraphQL. At first, GraphQL may be hard to start with. However, there are some really good resources, for example, boilerplates out there that will get you started really fast. And for now, GraphQL has not quite yet figured out how to do real-time, like having live queries, live event system, but that's actually researched. And some good solutions are coming up right now to tackle this problem of real-time capabilities. And finally, GraphQL is just a dumb execution engine. It's just going to execute what you tell it to execute. So obviously, it can lead to some pretty unoptimized situations. So when developing with GraphQL, you have to be careful about performance. You have to keep that in mind. And fortunately, Facebook helped with that. They proposed a library that is called Data Loader, and that we use in MovieQL. Since the MovieQL code source is open source, you can take a look and see how we did those optimizations. But you have to do some work in order to be able to have something production ready. So those resources are really important. We made the slides available online, so you don't have to take that. But you should start by going to the GraphQL website. It's been redone recently, and it's really well explained. Apollo Starter Kit is a good boilerplate to start with creating some GraphQL servers. And as well, you can take a look of what we did with MovieQL. And Apollo has also really good docs. You should also, if you're interested, check it out. So the presentation is available on this address if you want to get it. We're going to come back to this slide later. We want to thank all of those references that helped us do this talk. And finally, we want to thank you for your attention. I hope that you enjoyed it. And you can ask us some questions. We're going to be around. So come see us. Thank you.